Welcome to Public Health on Call, a podcast from the Johns Hopkins Bloomberg School of Public Health, where we bring evidence, experience, and perspective to make sense of today's leading health challenges. If you have questions or ideas for us, please send an email to publichealthquestion@jhu.edu. That's publichealthquestion@jhu.edu for future podcast episodes.
Hey listeners, it's Lindsay Smith Rogers. Today, a look at the hurricane forecast for the 2026 season. Michael Lowry, a hurricane and storm surge expert with WPLG-TV in Miami, joins me to talk about what we might expect, what it means to have a super El Niño in the mix, how AI is increasing the accuracy of forecasting, and where things have landed in terms of federal funding for research and forecasting. Let's listen. Michael Lowry, welcome back to the podcast. How are you?
Great. Thank you for having me. It's good to see you again.
It's good to see you as well. So you are our hurricane expert. You're joining us here from Miami. And we're recording this a little bit early in the hurricane season before things kind of really get cooking. And we're going to look out as to what some of the big topics are. But would you just kind of give us the lay of the land right now? What are we looking forward to in this hurricane season?
Sure. Well, we ended June with the least active hurricane season to date since 2014, so in 12 years. That's kind of the theme that we expect for the Atlantic hurricane season this year. Things are going to look and feel differently than they have felt the last decade, where we've had most of our seasons have been above average. Many of our seasons have been hyperactive in terms of their activity. We've seen some of the busiest hurricane seasons that we've had on record going back, over 100 years. That's not expected to be the case this year. It's going to be a quieter season overall. The one thing, though, we often stress is that it only takes one hurricane, and those bad hurricanes can form even in years where there's less activity. Examples of that are like in 1992. That was a very, very below active hurricane season. In fact, we only had one major Category 3 or stronger hurricane that year, and that was Hurricane Andrew. And it was a terrible hurricane, one of the worst hurricanes in modern memory. And, we'll maybe talk a little bit more about El Niño, but really the driving force behind the quieter conditions that we expect to dampen the Atlantic hurricane season is a very strong El Niño that's shaping up in the eastern equatorial Pacific. But again, even in some strong El Niño years, like in 1965, we had Hurricane Betsy. That was the first billion-dollar disaster to ever hit the United States. So big hurricanes can happen, but overall, we expect less activity across the Atlantic.
Well, let's get into what I've heard called a super El Niño. What does that mean? What is it?
Yeah, super El Niño is a term that isn't a scientific term per se. It's more of a colloquial term that people have used in the public. But generally speaking, let's kind of rewind a little bit and look out and see the big picture. El Niño is the warming of the waters around the equatorial Pacific in the eastern equatorial Pacific. So, those waters right around the equator. When the water temperatures, the departure from average reaches about 0.5 degrees Celsius, that's when we get into El Niño territory. This year, they're expected to be well above that 0.5 degree threshold. And when you get to about 2 degrees Celsius above average, that's when we get into what we would call a strong or super El Niño. And that's what's expected. And we're not, to be honest, Lindsay, we're not very far from that right now. This is an unusual El Niño in the way it's unfolding because it's unfolding so very, very quickly. We're just getting into July right now, and we're already seeing those anomalies approaching that 2 degrees Celsius mark.
How often do you see something like a super El Niño?
Not very often. We only had 6 that have been recorded in the record books. The records are a little more iffy when you get back past before, say, 1950 or so, but there's only been 6 that have been recorded going back to around 1850 in these super El Niños. The last one that we saw was in 2023, one in 2015, one in 1997. These El Niños they typically peak in the winter months. So the years that I'm telling you are the years that the El Niño sort of started, but then they can peak into the early months of the following year in December and January.
And so my understanding is that this is a cyclical thing that happens from time to time. However, is any of this related to climate change?
There's some element of climate change to it, and I think that's a research area that we're still trying to learn how much climate change is playing into the more frequent El Niños. The one thing that NOAA and scientists have done, though, is they've stripped the climate change part of the definition out, and they're using a relative El Niño index now. It's called the relative O&I. And what that essentially does is says that we know that the oceans are warming. They're warming pretty quickly. So let's take that part out of it, and let's just consider the relative warmth. And even when you do that for this year, those anomalies, those departures from average are already above 1 degree in the relative sense. So the contribution we think of global warming to that warmth is about a 0.5 degree Celsius. So that's where the difference is. We're getting about 1.7 degree Celsius anomalies absolute, and then about 1 degree Celsius in the relative sense. But they're aware of it and they're considering that. But even with the consideration, this is awfully, awfully impressive.
Can you explain why in an El Niño, particularly a super El Niño year, that impacts Atlantic hurricanes?
It's actually fairly straightforward in terms of why El Niño affects the hurricane season like it does. When you have very warm waters in the eastern equatorial Pacific, it means more thunderstorm activity. We see more storminess. Then the storms lead to stronger upper-level winds. Those upper-level winds, when they hit the top of the atmosphere, kind of move out in either direction. And in one direction, they head toward the Atlantic. And those stronger upper-level winds coming from the west at upper levels of the atmosphere increase wind shear. And wind shear is kind of like the shears on garden hedges, and they chop off the tops of thunderstorms that are trying to build up over the Atlantic, don't allow them to organize, kind of topple them over before they get very strong, and we see a reduction generally in hurricane activity. That's really it at its basic definition. It does other things in the Atlantic, but that's the primary thing that it does, is increases that wind shear.
We always like to talk about the public health impact. And so when we're thinking about hurricanes, obviously, we're giving people a little bit of a heads up. And one of the things that we've talked about in the past is the unpredictability and increasing uncertainty around predicting hurricanes and predicting impacts. And you've been talking a lot about how AI is coming into play with this. So can you bring us up to speed on what's happening there?
Yeah, it's been a really interesting evolution in terms of AI's contributions to hurricane forecasting, weather forecasting in general, but in my line of work, hurricanes specifically. Last year was really the first year that hurricane forecasters at the National Hurricane Center and at NOAA leveraged the new AI models for their forecast. And we saw really quite an advancement in terms of the accuracy of the forecasts. There are very specific examples of how they contributed to very specific forecasts. But generally speaking, the AI models, and in particular, Google has an AI machine learning-based model called DeepMind, really blew away expectations in terms of how good the forecasts were last year. And it was a new model that had been introduced, and it's using a number of different scenarios as we would do in traditional physics-based computer modeling. The difference, though, is the AI models are just kind of mimicking what humans do in terms of pattern recognition. It's just leveraging historical weather data and drawing up a forecast, not knowing anything about necessarily the physics of the atmosphere. So in traditional models, we use these big supercomputers that take up a lot of energy and take a lot of time to draw up a forecast. The AI models are trained on petabytes of historical data going back, over 100 years. But once they're trained, the models run really quickly. They're very efficient. We can get the results a lot more quickly. But I think the surprising thing is that they're not only competing with our traditional physics-based models, but in many cases, they're beating them.
When we had you on last year, it was to talk about the really horrific flash flooding that took place in Texas that killed so many people. And so this is a two-part question. The first part is, in a year of El Niño, should people still be on alert for these kind of crazy weather things that might crop up, especially in the summer months? And then the second part of the question is, how might AI help with giving people a heads up about this kind of thing?
Yeah, definitely. I mean, we've already seen an example of widespread locally catastrophic flooding from a tropical system. Back in the middle part of June, there was Tropical Storm Arthur, which was a very short-lived tropical storm. Was barely even a tropical storm. It was a named storm for 12 hours, but its remnants, it moved into Texas, and then its remnants moved into Louisiana, and it brought a tremendous amount of tropical moisture. Very, very similar in the sense of what happened around the 4th of July there in central Texas with the floods that struck there. All of this tropical moisture, you had a front that came down and just wrang out all of the moisture over the central Gulf Coast. Close to 2 feet of rainfall was reported. And in many cases, Lindsay, this is happening in a matter of hours. This is not something that happened over days. It's hard to fathom that amount of rainfall in a 6-hour period. So yeah, it happens any given year, and especially it can happen in an El Niño year. The subtropical jet stream is much stronger in El Niño years, and that can contribute to enhanced rainfall across these areas that are affected with this rich, abundant tropical moisture. Even when you don't have a named storm or a hurricane, that certainly plays into the heavy rainfall threats. In terms of how AI is helping us, it goes back to the forecasting and helping us with the forecast. I know a lot of the local offices and local officials are leveraging it to really help tailor their messages to folks. I think that's a really good use of AI. When we know there is a severe threat, is getting that message out to as many people as we can. The one thing, Lindsay, I will say is that AI models, in the case of Arthur, were the first onto it. They were the first ones to see, even before our traditional computer models could see what was happening. It kind of sniffed out that, hey, something may happen in the Western Gulf, a week or so out. So yeah, we're definitely using AI more and more nowadays, and it's helping us not only in messaging, but also in forecasting itself.
So I want to check in with you also about the status of cuts and how this is impacting your work. Can you tell us about that?
Last hurricane season was tough because we being meteorologists, being forecasters, were threatened with so many different possible cuts and budgetary restrictions that would potentially affect how we forecast and how we do our jobs. So, there were a lot of things that happened last year. There was a lot of pushback from meteorologists like myself and some of the requests that were made in terms of the federal budget, just to let folks know, like, this is really going to impact your forecast, where the rubber meets the road. What's happened over the last year is that while the administration is putting forward a budget that is fairly restrictive for operational forecasting for science in general, but I'm going to talk specifically about forecasting itself. Congress has come in during the appropriations process and corrected that. So for this year, the administration put a budget in that zeroed out some pretty significant offices, just like they did last year, that would affect hurricane forecasting. But already the House subcommittee has come in and added those offices, added those items back in. And that's kind of what we have seen in terms of the give and take the last few years, is while the administration may put forward a budget that's very lean and appears that, it could affect forecasting, Congress has come in a bipartisan way, and both the House and the Senate have come in and not only added, the money back in to support forecasting that we need, but also increased it in some cases. So one of the line offices that was particularly concerned about last year was the Office of Oceanic and Atmospheric Research at NOAA. That's the research arm of NOAA, but it also houses many of these climate and forecasting laboratories, including the Hurricane Research Division in Miami. That was threatened in terms of having everything taken away from it last year. That particular office, OAR, has not only had seen their budget back, but they've seen an increase in the budget this year. So largely speaking, there have been positive developments in terms of the money and the appropriations in the budget for forecasting, specifically about hurricanes and hurricane forecasting, since we've last spoken. And that, unfortunately, is not an across-the-board thing. I realize there are a lot of, particularly on the research side, there are a lot of programs that are still being threatened and programs that have been cut. And those do affect us. But from the operational standpoint, we're sitting in a much better place today than we were a year ago.
That's very encouraging. So if I were to sum up our whole conversation, we might have a bit of a quieter hurricane season. Doesn't mean we won't have any hurricanes. Still should be on the lookout for extreme weather. And it sounds like AI may be playing a role in helping us kind of better anticipate and maybe even provide very hyper-local forecasts. Does that sound about right to you?
That's it. Yeah, we've been we're in a fortunate place here where we have more data, more tools at our fingertips than we ever have, and we're finding new ways of utilizing them. And in terms of AI, I do remind people that the humans are always going to be part of the forecast. The conventional computer models are always going to be necessary. AI can't give us necessarily the very fine details of hurricane structure that we need to make better forecasts. So there's always going to be a human in play. But the type of AI that we're using, this machine learning-based AI, is really smart and it's impressive. And Lindsay, compared to other types of AI that folks may be more familiar with, like generative AI or large language models, the chat box prompts that folks use maybe on a daily basis, the AI models in weather forecasting had the potential of using less energy, drawing less water than the conventional physics-based models that have to lean on these very large supercomputers. Some of these AI models actually can be run on laptops. They're very efficient.
That's actually very good news to know because, we're talking about climate change here, so energy should come into the conversation. Well, Michael Lowry, thank you so much for returning to Public Health on Call. We always appreciate your insights, and we, of course, will check back in with you on the forecast.
Thank you. It was a pleasure to be with you.
Public Health on Call is a podcast from the Johns Hopkins Bloomberg School of Public Health, produced by Joshua Sharfstein, Lindsay Smith Rogers, Stephanie Desmond, and Rachel Walsh. Audio production by Michael Bonfils, Matthew Martin, and Philip Porter, with support from J.B. Arbogast, Spencer Greer, and Chip Hickey. Distribution and social media by Rachel Walsh, with support from Nick Moran and Brianna Iacovelli. Follow us on Instagram and Blue Sky at Public Health Pod for more public health takes and special content. If you have questions or ideas for us, please send an email to publichealthquestion@jhu.edu. That's publichealthquestion@jhu.edu for future podcast episodes. Thank you for listening.